welcome to Easy Electronics. This is a video on ISRO Scientist Electronic Post Preparation, and we are going to see some more questions from the analog circuits subject. Let's see what is the first question. The H parameters of the circuit is dash. Okay, so a circuit is being given and we need to find its H parameters. So there are four options given. It is given in the form of 2 by 2 matrices. Okay, so what are H parameters? So before answering this question, let us see what are the basics of H parameters. H parameters means they are hybrid parameters, and for a two-port network, this is a two-port network consists of an input and an output port. Okay, and the H parameters are obtained by exciting the circuit with current I1 and voltage V2. Okay, so the current here in the input be I1, this is the current, and the voltage be V2 at the output. Okay, now we know that the current here is I1 and the voltage in the input be V1. This is the voltage across the input ports or in the input port, and the current in the output terminal or output port is considered as I2. So this is a what? This is a two-port network. Okay, now we have excited the circuit or this network using current I1 and V2, and we are going to write the equations for the voltage V1 and the current I2. Okay, so the voltage V1 according to the hybrid parameters, if we are defining the voltage V1, then it will be V1 is equal to H11 I1 plus H12 V2. Okay, similarly, write the equation for I2, and if you write the equation for I2, it is defined as I2 is equal to H21 I1 plus H22 V2. Okay, so this is the two characteristic equation, and these are hybrid parameters H11, H12, H21 and H22. And if you write the matrix form of a hybrid parameter or a hybrid matrix, it will be H11, H12, H21 and H22. Okay, you can write the equation for H11, H12, H21 and H22 by making these other terms as 0. That is, if you want to find the equation of H11, make this term as 0. That is, H11 will be equal to V1 by I1 and so here we are taking that V2 is equal to 0. Okay, similarly, that is, just assume that if you want to find the equation for this one, make this term as 0. Also, H12 will be equal to what? Here, take this term as 0, then V1 by V2. So here what is 0? I1 is 0. So similarly, you can write the equations for H21 is equal to I2 by I1 and H22 is equal to I2 by V2. Okay, so these are the equations. Now for each of these values, here for H21, the value of V2 is 0. Similarly, we are making the corresponding currents and voltage associated with the other term is 0, or the equations for H11, H12, H21 and H22 are this. Okay, so this you can simply study if you know this equation, or you don't need to by heart it, you can write it from the equation directly. Okay, now what is being asked in this question? We need to find the values of these parameters, that is H11, H12, H21 and H22. Now in the question, they have given a network with a certain voltage and currents and two resistors connected, and we need to find the value of these hybrid parameters. So let us try to do that. Now we have this characteristic equation, right? That is V1, we have the equation for V1 and I2 in terms of the hybrid parameters. So let that be 1 and 2, your equation 1 and 2. Now what I am going to do is I am going to find the value of my hybrid parameters by applying Kirchhoff voltage law and Kirchhoff current law into this network. That is, what I'm going to do is, I'm going to apply Kirchhoff voltage law in the input port. That is, this is my input port, this is my output port, right? So, in my input port, I'm going to apply the Kirchhoff voltage law. So, what is Kirchhoff voltage law? It states that the algebraic sum of voltages present in a closed loop or a network is equal to 0 at any instant of time. And also we are following certain sign conventions here. If we travel from negative to positive, the voltage is taken as positive. And if we travel from positive to negative, the voltage is taken as negative. So I have explained it in detail in my earlier video, that is the video on Kirchhoff voltage law. So if you want to see that, please watch it. I'll share the link in my description box. Okay, so here I'm going to apply what? KVL in my input port. So I'll get this V1, that is V1. Then the voltage across this 10 ohm resistor, that is resistor value into current flowing through it. The current flowing is I1. So it is minus 10 I1. Then here, you know that this voltage is equal to your V2. So minus V2 is equal to 0. So taking these two terms to the other side, then V1 is equal to 10 I1 plus V2. Mark this as your equation number 3. Okay. Again, I am going to apply Kirchhoff current law for this node. So what is Kirchhoff current law? It states that the algebraic sum of current flowing into the node is equal to algebraic sum of current flowing out of the node. So applying KCL. This is KCL is Kirchhoff current law. So what are the currents flowing into the node? It is I1 and I2. So I1 plus I2 is equal to, what is the current flowing through this resistor or this terminal or this branch? It is 10. There is a 20 ohm resistor. And what is this voltage? It is V2. So current value is equal to voltage by resistor value, which is equal to V2 by 20. So this is your equation number 4. Now, if you see this equation number 4 and equation number 2, actually we need two equations to equate with this standard equation, right? So we already have equation for V1. We need an equation for I2. So make this in the form of an equation in terms of I2. So I2 is equal to V2 by 20 minus I1. Let this be your equation number 5. Now what I'm going to do is, in order to find this H11, H12, H21, H22, I'm going to equate these 4 equations. By looking at your equation number 1 and your 3, see, it is V1 is equal to H11 I1. So here it is 10 I1. So what is the value of H11? It is 10. Okay. Plus V2. Here it is plus H12 V2. So what is the value of H12? It is 1. This is very easy, right? If you know this equation, this is very easy. Now you need to think that how to form an equation similar to this equation so that you can equate both. So we have got the values of H11 and H12. Similarly, look your equation number 2 and your equation number 5. In equation number 2, what is given? It is I2 is equal to H21 I1. Here it is minus I1. So if you want to rearrange this, form it in the form of minus I1 plus V2 by 20. Anyways, we can look and identify it. Okay. So it is H12 I1. Here it is minus I1, means the value of H21 is minus 1. H21 and here it is minus 1. So it is minus 1. Then plus H22 V2. Here it is 1 by 20 V2. So it is 1 by 20. Okay, so this is the H matrix for this 2-port network. And if you see the options, can you see any 10? Yeah. There is a option here, 10, 1, minus 1, 0.05. Okay, you can write this 1 by 20 as 0.05 or 0.05. Now this is your H matrix or H factor matrix. Okay, so the correct option here is your option D is your hybrid parameter matrix for this particular network. Okay, so I hope it is clear. So let's see what is the next question. The pole zero plot corresponds dash. So this is actually a pole zero plot and it corresponds some filter. What is that? A low pass filter, B high pass filter, C band pass filter and D notch filter. Now, what is a low pass filter? Let us discuss the terms first. Low pass filter means a filter which allows only lower frequencies to pass and it cuts off upper frequencies or higher frequencies. Such type of filters are low pass filter. And if you see the pole zero plot of a low pass filter, it will be like this. There is an imaginary axis, there is a real axis, and the pole zero plot for a low pass filter will be having a pole value of minus omega h, where this is the upper cutoff frequency. So if you see a pole zero plot like this, you should be able to figure out that this is the pole zero plot of a low pass filter. So this is the case with a low pass filter. It will cut off all upper frequencies or higher frequencies. Okay, so upper cutoff frequency is minus omega h and it is marked as a pole here. Now, what is the option B? This is a high pass filter. High pass filter means it passes only higher frequencies and it cut off all the lower frequencies. Okay, so the pole zero plot will be like this. There is a j omega axis, there is a sigma axis, there is a minus omega L. This is the lower cut off frequency. Also, there is a zero value at the origin. So this is the pole zero plot of a high pass filter. The magnitude response of a low pass filter, if you draw it roughly, how it look? The magnitude response of a low pass filter means it passes all the lower frequencies and it cut off all the higher frequencies. So it will be like this. And for a high pass filter, how will it be the magnitude response? It will be like this. That is, it cut off all the lower frequencies but it passes all the higher frequencies. So it will be like the reverse. And the third option is band pass filter. So what is actually a band pass filter? It passes only a particular band. And such type of a filter is called a band pass filter. And if you see the pole zero plot of a band pass filter, the band pass filter will be having two frequencies, that is lower cutoff frequency and upper cutoff frequency, because it passes only a band. Likewise, like this. So it passes only a particular band. So it is having a lower cutoff frequency and a upper cutoff frequency. So it is having minus omega h and omega L, which are upper cutoff frequency and lower cutoff frequency, and there is a zero at the origin. So this is imaginary axis, this is the real axis. So it will be like this. And here the value of upper cutoff frequency is greater than the lower cutoff frequency. So this is a band pass filter. Now, if you see these three pole zero plots, now it is clear that the given pole zero plot is the answer for what? Your last option, which is a notch filter. Now, if you are not familiar with the term notch filter, don't get confused. It is a band stop filter. So we have discussed low pass, high pass, band pass, and now there is another type of filters which is called band stop filters. Now, if the band pass filter is passing a band, then the band stop filter is stopping a particular band of frequency or a range of frequencies. It will be stopping. So that is a band pass filter. Now, what is the notch filter means? The notch means a small opening or a small curve. It is a notch. Now, this notch filter type of band stop filters will have the band to be stopped is very narrow. That is, it stops only a narrow band. Okay, I hope it is clear. That is, notch filters are type of band stop filters. And what the band stop filters are doing? The band stop filters are stopping a particular band, and in the notch filter, the band to be stopped is very narrow, a small band. So that is a notch filter. And this given pole zero plot is a pole zero plot of a notch filter, because it is having two values, that is two poles, and two zeros are present in the imaginary axis. Okay, so the given question or this pole zero plot corresponds to your option D, which is a notch filter. And also this value is your minus omega L, and this is your minus omega H. So here it is minus omega L and minus omega H given, and your omega L is greater than your omega H from this figure. So the given question is giving a pole zero plot of a notch filter. So the correct answer for this question is option D. Voltage gain of amplifier is dash. So this is a operational amplifier circuit given, and you need to find the gain. What is gain actually? Gain is the ratio of voltage output to voltage input. That is V out to V in is your gain. Now we need to find the gain of this circuit, and if you closely examine this circuit, this is an operational amplifier, and the input is given to which terminal? It is given to the inverting terminal. Okay, and the non-inverting terminal is grounded. So this is a what type of an amplifier? This is a inverting type of ideal operational amplifier. And also we know that for an ideal op-amp, the current drawn to the input is 0, and the differential voltage present in the input is taken as, or in the input terminals are taken as 0. So this is V minus and this is V plus. V minus is equal to V plus is equal to 0. That is, the differential voltages are taken as 0 for a ideal operational amplifier. Now we need to find the value of V out to V in. Okay, so let us consider this path. That is, there is a V1, there is a resistor connected, that is R1, there is a node here, and that is I'm going to take this path. Okay, this path I'm going to take. So again there is a resistor R2, then there is V out. Okay, so if you stretch this path, you will get V in, R1, R2, then V out. Okay. Now, what is the current? The equation for current I in this path. Current I is equal to V in minus V out by R1 plus R2, right? Okay. And if you see here, there is a node here. Let the voltage in this node be V2. Okay. This V2 or the voltage, this voltage V2 will be equal to what? This voltage V2 is equal to V negative, which is equal to 0, because we know that the differential voltage at the inputs of a ideal op-amp is 0. This voltage is equal to this voltage, and hence V2 is equal to 0. Now, if we split this equation in terms of this V2, how can you write it? We can write it as, that is, I is equal to Vi minus V2 by R1 is equal to V2 minus V out by R2, right? We can write it like this, or that is, we are splitting the equation in terms of V2. So this current is equal to this current, right? Because how can you say it like that? Because this is a series path. So the current is same. This current is equal to this current or this current. So the current is same. So you can write this equation like this. I hope this is clear. Because the current flowing through a series network or a series path is same. So you can write this equation in terms of V2 like this. So Vi or V input minus V2 by R1 is equal to V2 minus V out by R2. Now we know that V2 value is equal to what? V2 is 0. So you can write or remove this V2, or you will get an equation like this. Okay, so equating this two, how will you get the value of V out by V in? That is, if you take this Vi to this side, take this R2 here. So minus V out by V in is equal to R2 by R1, or you can write V out by V in is equal to minus R2 by R1. So this is the equation for your gain. And how we have found it is by taking this path. Or simply, if you don't know any of this thing, just as I said earlier, this is a what type of network? This is the inverting type of operational amplifier, right? And the equation for gain of a inverting operational amplifier is V out by V in is equal to minus RF by R in. This is a standard equation for the gain of a inverting op-amp. That is, V out by V in is equal to minus RF by R1. So if you examine this, you can see this is your RF. This is your Rin. So you can write it like minus R2 by R1. So this is what we have also obtained from this path. Okay, so this is how you have to find the gain of the operational amplifiers. That is, you have to take the path and you have to solve the equation for current, and you have to keep these things in mind, that the current drawn to the input is 0 and the differential voltage is taken as 0. So by keeping this, you can solve this question very easily. And the correct answer for this question is your option A, which is minus R2 by R1 is your equation. So these are the questions which I have included in this video. So while explaining each question, I've tried to include at least 2 or 3 informations along with those questions, so that you should be able to gain those information if you are not familiar with such an area or a topic. So I hope this video was useful for your preparation. If yes, please do give this a thumbs up and also share this video with your friends. And if you want more preparation videos on ISRO or GATE or technical assistant exams or the core subjects of electronics, please do subscribe to the channel.